Hello everyone. I told you I would make you a video, and this is the video for C and D. I'm sorry it's taken me so long to get through to make this video, but just to let you know, I will know if you watched it or not, so you need to watch it. I'm going to track it on Canvas. So this stuff that we're doing is not super easy. It's one of the harder topics that students say in all of calculus, just because you're getting used to looking at spaces and you got to be really good at graphing. But we do graphing and look at spaces and do different things throughout the rest of calculus. So it's important that you can grasp this right now as we go through it. So I know that a lot of times I say work the odd problems in the back, but it would help you a lot if you go to like number 13 or number 15 or whatever problems around this in the back of the section, and then look at the solutions at calcchat.com. That may help you a little bit. I would practice those, because if you can do the ones from the book, you should be able to do the ones that we put on the test. So, and this is just the disk and washer method. So some problems are disk method. If there's no missing space, if there's no missing space like this, then it's a disk method problem. And then one little change is if there is missing space, it's a washer problem. So you got to know what formula to use. And, with the washer, we have to subtract out the missing stuff. With the disk, we don't subtract out the missing stuff. So, but I told you I would work through C and D. So I want to go ahead and work through those. We worked through A in class, and I think maybe B. I want to look through C and D now. So it's going to be the same graph as before. That's why I just copied the graph down again. So it's going to be that same space, except on C we are going about the line y equals 8. Okay, and so where is the line y equals 8? So it's still the same bounded region in here. It's still all this, and this might go through the lines a little bit, but it's still all this stuff right here. But we're just going about y equals 8. So you got to know where y equals 8 is. So you go to where y equals 8. All right, and then I'm going to draw a line, horizontal line. Okay, and so if we are going to revolve about y equals 8, you can see how the very tip top of this thing touches y equals 8. Okay, so imagine what that would look like if we took this two-dimensional space and we revolved it all the way around the line. So all the way around, not just halfway, but all the way. So to me, it would kind of look like a dog bowl. If you think about what your pet, you know how it has kind of a rim and it's circular on the outside? Because this straight line, whenever it's revolved all the way around, does make a circle. All right, but how it's kind of thicker on one side and then it goes down to keep, I guess it's so that when the dogs are eating that food, they won't be knocking it out. So it's got kind of a thicker edge on it right here. And that's kind of what it reminds me of. And it's not going to have a hole in it at all. In the bottom, sorry, it's not going to have a hole, but it would be on the inside. We're going to be missing some stuff, right? Because that would be where you would put the food in the bowl, right? So this is, and if you looked at it in 2 dimensions, 3 dimensions, it's going to look like this if it was over on its side. But again, the bottom would be circular, right? And the top would be circular because that tip on the top would make a circle. So you actually would be able to see that. And you just have to imagine that this bottom is circular as well. All right, and there's a bunch of missing space inside. Because this does have some thickness to it. You see, this is going to give you a little thickness there. So if it was made out of, I guess if it was made out of, say, plastic, then all this on the, it'd be thick right here. It wouldn't just be hollowed all the way. Anyway, all right, so when we set this up, it says we want to revolve about y equals 8. And y equals 8 is a horizontal axis of revolution. So with a horizontal axis of revolution, remember you want your equations y equals x. Okay, and we know we're going to be missing some stuff whenever we revolve it. So we're going to have a capital R of x. That's going to be our outer radius. and we're going to have a little r of x. This is what we're going to subtract out, the missing stuff. That's going to be the inner radius. All right, so the outer radius, think about what the radius is. It's the distance from the center to the outside of the figure. The outer radius is going to be constant here. It's just going to be this distance from here to here. So it's just going to be 8. So capital R of x for this problem, going about y equals 8. The outer radius is just 8, because that's a distance of 8. Now the inner radius is going to change, right? So, you know, if I'm way over here at the tip of the bowl, then it's going to be this long. But if I'm inside the bowl, it's going to be, you know, the radius might be this long. So you want to think about those rectangles. And we're still subtracting out those rectangles. Well, before, I guess we were adding rectangles. Now it's like we're subtracting out an infinite number of those rectangles inside. All right, and the height of each rectangle is going to depend on the top curve and the bottom curve. So when we're inside the figure here, we're going to say top curve minus bottom curve. All right, and so what's the top curve? Well, the top curve would be y equals 8. So I'm doing my inner radius. 8 minus the bottom curve. All right, and this is actually a curved curve, right? Not just a line. All right, and so the bottom curve was, I think it was y equals 2x squared. Yeah, it was y equals 2x squared. So the inner radius is top curve minus bottom curve. It's going to be 8 minus 2x squared. All right. So now we have what we need for our formula. We only need one other thing, and that's going to be the boundaries on the integral, right? Our volume is equal to pi times the integral of, well, since our equations are y equals x, or since we have a horizontal axis of revolution, we use x boundaries. And our x boundaries were 0 and 2. And then, so that since I know this is a washer problem, right, because I'm going to have, what I'm doing whenever I plug this first one in is it's like I'm making the whole figure. And then whenever I subtract this out in my formula, it's like I'm taking that inside missing piece out. Okay? And so what's my formula? My formula is capital R of x squared. So it's going to be 8 squared minus, and then little r of x squared. So it's 8 minus 2x squared squared. Now remember, when you square a binomial, that doesn't just mean square the first term and square the second term, right? That's the binomial, and it doesn't mean just say that squared and that squared. You have to say 8 minus 2x squared times 8 minus 2x squared. All right, you'll notice on the homework you're going to have a crazy equation where you have a square root that you actually have to, it's like, I forget, it's like 8 minus the square root of 4 minus x. But you still square it the same way. You still full it all out. And you'll see, since so many of you have started on your homework, which I did check earlier because I was interested, I'm sure that you've seen that problem. And just know, whenever you square a binomial, you have to full it out the whole way. All right, so you got to distribute. So that's going to be 64, and then I have minus 16x squared, and then minus 16x squared, and plus 4x to the fourth. All right, and then of course I want to put those two like terms together. I have 64 minus 32x squared plus 4x to the fourth. All right, and that, all of this is what goes in that parentheses. And I'm subtracting it. Okay, so I have to be careful because I need to distribute that negative to everything. So I have pi times the integral from 0 to 2 of 64. And then it's going to be minus, so I'm going to subtract all three of these terms. So minus 64 plus 32x squared minus 4x to the fourth. Again, I'm subtracting every term. And so you see my constants cancel out here. And I'm just left with an easy integral. Not hard at all. It's just 32x squared minus 4x to the fourth. All right. And so now integrate and evaluate. So I'm going to integrate. That's going to be 32. We do have a pi in front. Can't forget that pi. All right. I never forget about pi. I got 32x cubed over 3 minus 4x to the fifth over 5. I like to kind of keep my fractions in front. It just makes more sense in my head if I do that. But you can do it ever how you need to make it make sense. All right, and then I evaluate that from 0 to 2. So I have to plug in the top boundary first and then the bottom boundary second. So I have pi times, if I plug in a 2, that's going to be 32 over 3, and then 2 cubed is 8. So times 8 minus, and then that's going to be 4 fifths, and then 2 to the fifth power, that's going to be 32. All right, and then when I plug in a 0 here and here, I get out a 0. Now, in one of your homework problems, you'll notice plugging in a 0 is not going to give you a 0. So you need to make sure you always check that what happens when you plug in a 0. All right, so now let's bring up my good old calculator. So it looks like my common denominator is going to be 15. And so I'm going to take this number right here, 32 times 8. Since my common denominator is going to be 15, 3 goes into 15 5 times. So I'm going to say this number times 5. All right, so 1280 over 15 minus and now I'm going to take this 4 times 32. All right, and then 5 would go into 15 3 times, so I'm going to say this times 3. That's 384 over 15. All right. Bring my calculator back up. So I'm going to say 1280 minus 384. All right, so I get 896 over 15 times pi. So 896 over 15 times pi. All right, and that's the right answer for that one. So that will be the volume of that figure. Now, for part D, instead of going about a horizontal line, y equals 8, part D, we're going to go about the line x equals 2. So let's look here. Well, I already had an x equals 2. All right, that was part of my boundary. But this is where I'm going to go around. I'm going to put this, and I'm going to go around this line, x equals 2. And it's all this stuff inside here. All this is going to go around that line. Now, just imagine, I do it with rainbow because it makes it a lot more fun. Just imagine what that would look like if it revolved around that line. It's not going to have any missing stuff in it. It's going to be a solid, kind of like a nail, I guess, if you think about it. Because this tip right here, if you revolve it around the line, you revolve it all the way around the line, then it's going to make a circle here on the end. And this thing gets slimmer and slimmer as you go up to the top. It gets thinner and thinner. And it would come to a point. All right, and so that's also going about this line x equals 2. So it would kind of look like a nail. You know, that's my best description of it, I think. Or screw or something like that. maybe even a tornado, if you turn it over the other way. That's a little scary. So let's just think about a nail or something like that. All right. So since there's going to be no missing stuff in here, no missing stuff anywhere, then it's going to be a disk method problem. Now remember what we're doing. We're taking these rectangles, and if I go around a vertical line, I have horizontal rectangles. So I'm taking these rectangles, an infinite number of these, and I'm revolving them about the vertical line. And every time you revolve it all the way around, it makes a disk, right? It doesn't make a washer. It makes a disk because it's going to be solid. It's not going to be missing any pieces. All right, and we do our integral, and our integral, what it's going to do is it's going to sum up an infinite number of those disks, and we'll find the actual volume. The problem is I need to know the height of each one of these rectangles. All right, and since I have multiple curves here, I'm going to need to figure out the height by looking at the equations. Well, what was our equations? We were given one equation. It was y equals 2x squared. Well, I'm not going to use that equation written like that. Why is that? Because I have a vertical axis of revolution. Remember, with the disk method, if you have a vertical axis of revolution, your formula is pi times the integral from C to D, and these are both y intersection points, or y points, and then it's r of y squared, dy. And so what r of y, you know how f of x is equal to y? Well, r of y is equal to x. So we want our equation x equals, every time we have a vertical axis of revolution, we want x equals. And we did that, remember, we did that up here, I think it was in this problem where we had our vertical axis, the y-axis on part A. We did that. And we actually changed over this to x equals. And so it's real easy to change over to x equals, right? You just divide both sides by 2. So you'll have x squared equals y over 2. And then take the square root of both sides. And since we're only on the right side, it's only positive y's, and we have positive x's here. We're just going to have x equals the square root of y over 2. We're not going to have a plus or minus like you might would think. Plus or minus would mean both sides. We're just taking one side and revolving it about this line. All right, so we know this is this curved part in here. That's x equals the square root of y over 2, or y equals 2x squared. They mean the same thing. That's the inside part. The part that we're revolving about is x equals 2. So remember when we were finding the area between two curves, how we had to find the height of the rectangles to sum up an infinite number of those? If we have x equals y like this, you have to say right minus left. The problem that we worked earlier, we said top minus bottom to get us the inside part, to get us the inner radius. Well, here we don't have an inner radius, we just have one radius, just an outer radius, because we're not missing anything, and it's x equals y, so we have to say right minus left. Well, the right curve is 2, so that means my r of y right there, that's going to be 2 minus the left curve, right curve minus left curve. So that's going to be minus the square root of y over 2. So that's what I want to plug in, and that's what I want to square. And that's going to take a little math to square that, all right? It's not just, you can't just square the first term and square the second term. So let's do that real quick. So remember our boundaries, they need to come from the y. Well, this is y equals 0 down here. What was this up here where we intersected? Do you remember? It would be when x equals 2. So when x equals 2, that would be 4 times 2, or 8. All right, so it's from 0 to 8, and then we need to plug in this and square it. You probably want to do that over to the side, All right, so that's the square root of y over 2. So we have 2 minus the square root of y over 2 squared dy. So I am just going to do that. I'll do it over here on the left side. So I have 2 minus the square root of y over 2 times 2 minus the square root of y over 2. All right, so I'm going to distribute. So 2 times 2 is 4. And then 2 times a negative square root of y over 2 is going to be negative 2 square root of y over 2. And then when you multiply negative square root of y over 2 times 2, that's negative 2 square root of y over 2. And then when we say negative square root of y over 2 times negative square root of y over 2, we get positive y over 2. All right, square root times square root, that just goes away. Now these are like terms, so we need to put them together. All right. And also remember, if you have the square root of a fraction, you can take the square root of the top or of the numerator over the square root of the bottom or the denominator. All right. So the reason why I say that is we're going to put these two things together, and we're also going to bring out the denominator since it's a constant. So this will be 4 minus, all right, we got negative 2 and negative 2. So that's going to be minus 4 over the square root of 2. I'm taking the square root of the bottom, and then the square root of the top I'm going to write to the side. So remember, square root is to the 1/2 power. All right. So again, all I did is I took the square root of y over 2. That's the square root of y over the square root of 2. The square root of y I'm writing as y to the 1/2. The square root of 2 I'm just leaving as the square root of 2. All right. So that's what I get when I put those two terms together. And then I have plus y over 2. All right, so that's what I want to integrate. So I'm going to plug that into my formula. I got 2, I have 4. 4 minus 4 over the square root of 2. We'll change that around if we have to. Times y to the 1/2 plus y over 2. Or that's 1/2 y, ever how you want to think about that. All right, so now let's integrate. So I have pi times the integral of 4 is 4y. Now, integrating here, remember you add 1 to the power and divide by the new power. When you add 1 to 1/2, you get 3/2. So when you divide by 3/2, that's like multiplying by 2/3. So I'm going to multiply this by 2/3. So if I multiply the numerator by 2, that's going to give me 8, right? Again, 3/2 power, divide by 3/2, multiply by 2/3. It's going to give me a 3 on the bottom. I'll leave that square root there for now, but we may have to change that over. And then it's y to the 3/2 power. So add 1 to the power, divide by the new power, and that's what we get, the constant in the front. And then we're going to do the same here. Add 1 to the power, so it will be y squared. And when you divide that by 2, it's not 2 divided by 2. It's like 2 times 1/2. Or 1/2 times 1/2. So it's over 4. That's why I like to think about that like it's 1/2 y. Because then, whenever I add 1 to the power, you know, I'm adding a 2 and I divide it by 2, I'll have 1/2 times 1/2 to give me the 1/4. All right, I have to evaluate that from 0 to 8. And then I should have my answer. Let's see. So I'm going to plug in an 8 everywhere. So I'm going to have pi times, got 4 times 8. Then I'm going to have minus 8 over 3 square roots of 2 times 8 to the 3/2 power all right, and then plus 8 squared is 64 divided by 4. All right, and then what happens before I put my bracket? When I plug in a 0, we got to double check. That's a 0, That's a 0, and that's a 0. So it'd be minus 0, 0, 0, minus 0, minus 0, plus 0, whatever you want to say. But we don't do that. We don't want to add or subtract 0 if we don't have to. It's just less for us to write. All right, so I have pi times 32. Now, I'm going to have to do some stuff here, some actual stuff. So how do I say 8 to the 3/2 power? Well, remember, 8 to the 3/2 power, let me write it up here. 8 to the 3/2 power means the square root of 8 cubed. And the square root of 8 is 2 square roots of 2. So it's going to be 2 square roots of 2 cubed. So I'll say 2 times 2 times 2 on the outside. That'll give me 8. And then square root of 2 times square root of 2 times square root of 2 is square root of 8. So I have 8 square roots of 8. Well, that's going to simplify a little more because the square root of 8 is 2 square roots of 2. So 8 square roots of 8, if this is 2 square roots of 2, that's going to make that, let me write down what I had before. So I have minus 8 over 3 square roots of 2. Again, I need to simplify this. So if that's 2 square roots of 2, that's going to be 16 square roots of 2, right? Because 2 square roots of 2 times 8 is 16 square roots of 2. And then plus 64 divided by 4, I'm going to guess that is 16. I think I guessed pretty good. I think that's what it is. All right. So now I can cancel out here and here. See that? Because the square roots cancel out. I do need to put these numbers together. These are all numbers now. I have 8 times 16 over 3. 8 times 16 over 3. So let's bring our calculator back out. 8 times 16. So that's going to be 128 over 3. So pi times 32 minus 128 over 3 plus 16. All right, so I'm going to get a common denominator down here between these three terms. It's going to be 3. All this is going to be times pi. I'm going to write the pi on the right side. All right, so I got to figure out what to put up here. So since this doesn't have a denominator, I say 3 times 32. So that's going to be 96. Minus, this one already has a denominator of 3, so that's 128. Plus, this one doesn't have a denominator, so I say 3 times 16, and that gives me 48. So probably want to do that in a calculator, especially if it's late at night and you're working on this last minute. Not that you're going to do that, because I know you're all good students and you probably already have this, all worked out. And you're checking your own work right now, right? So this is 96 minus 128 plus 48. All right, so I get 16. So my top number is going to be 16. So that's 16 over 3 times pi. All right, so that is the volume of my figure, my nail, or my inverted tornado, or whatever you want to call it, is what it would be in 3 dimensions. So it's that many cubic units. 16 over 3 times pi cubic units. All right, so again, I would, if some of this doesn't make sense, watch the video again. Look back through your notes where we worked some of this stuff. Try to work the odd problems. They'll help you too. And remember, calcchat.com. You can go there and get the solutions to, and we're in 7.2. You can get the solutions to the odd problems, not just the answers, but you can get the solutions. Also, I tell my students sometimes, and I know it's kind of cliche to say Khan Academy, but if you just aren't getting this and you need more videos, that guy Sal at Khan Academy, if you look I would look up the disc method and the washer method. He does a really good job of going through, and he probably explains a little bit better than I do, but I'm a lot more funny than he is, so we'll take that. Take it how you want it. Anyway, I'm just kidding with y'all. You'll have a great day and a good weekend. I hope your homework goes well, and I hope this video really helps. Have a great evening.